Good morning, boys. Today we are going to deal with two fractions at the same time when we are adding and subtracting fractions with same denominators, alright? And then during the next lesson we're focusing on fractions having different denominators. But first of all, for today's lesson we are focusing on same denominators. Now fractions, boys, can be added and subtracted, alright? And it is much easier to add and subtract fractions when the denominators are both the same number. That means the two fractions have the same denominator, okay? Now let's start with adding fractions, okay? I have this diagram, boys. I have 5 squares. I have one of them colored blue, right? And 2 colored orange. And the question is, as a fraction, how many of the boxes are colored, right? Since we have 5 boxes, the fraction, right, is always out of 5, right? The denominator is always 5 because I have 5 boxes, right? But first of all, we need to know the denominator. And here, the denominator is 5, all right? Since I have 5 boxes. Secondly, we need to find the fraction of the colored boxes. I need to find the fraction of the blue boxes, and I need to find the fraction of the orange boxes, all right? And then last of all, we need to add these two fractions together to find the fraction of boxes, all right, which are colored, okay? Because we have blue colored boxes and orange colored boxes, all right? First of all, adding fractions. In the above example, as a fraction, how many of the boxes are blue? And we have just 1 out of the 5 boxes, so the fraction of blue boxes is 1/5. 1/5 of the boxes are blue, okay? As a fraction, how many of the boxes are orange? Right, I have 2 boxes which are orange out of a total of 5 boxes, alright? So 2/5 of the boxes are orange, 1/5 of the boxes are blue. So now, boys, we have our 2 fractions, alright? To find the fraction of boxes which is colored, right? So fraction of colored boxes, all right? It is 1/5, all right, plus 2/5, all right? 1/5 which is blue, 2/5 which are orange. Let's not work it up till now. Let's discuss another example first. Jessie and James share a chocolate bar. Okay? Jessie eats 2 parts out of a total of 7. The chocolate bar is divided into 7 equal parts, and Jessie eats 2/7 of it, all right, as you can see in the picture. Because Jessie is eating 2 parts out of, the 7 parts, because the chocolate is divided into 7 parts. On the other hand, James eats 4 out of 7 of it, because James is eating 4 parts out of a total of 7, okay? As a fraction, how much of the chocolate bar did Jessie and James eat all together, boys, all together? So I have the fraction of that Jessie eats. Jessie eats 2/7. I have the James fraction. James eats 4/7. Since I need to know the fraction all together, all right, all together, I need to add 2 sevenths plus 4 sevenths. Now, let's see how many of the parts did they eat all together. They eat two. Jesse eats 2 parts, James eats 4. So all together they eat 6 parts, all right, out of a total of 7. So they eat 6 sevenths, all right. Look what's happening, all right. I didn't add them, I just added the parts up till now, all right. I looked at the diagram and added the parts. Now, there's a question. Think, what happens when the denominators are the same? So 2 sevenths plus 4 sevenths, if I look at the above example, the answer, all right, if I add the 2 parts, the Jesse's 2 parts and James 4 parts, I end up with 6 parts in all. But those are 6 parts out of 7. So what happens when the denominators are the same? When the denominators are the same, we just add the numerator. So let's write it down. We just add the numerators. So we just add the numerators. Let's work another example. Now, now we are asked to evaluate, find the value of, and give your answer in its simplest form. That means that if the fraction can be reduced to its lowest terms, I have to reduce it to its lowest terms, okay? So, boys, 1/5 plus 3/5, okay? Denominators are the same. So the number of parts that the diagram, all right, is divided into is going to remain the same. I just add the numerators, all right? So the denominator remains the same. I'm going to use a color, all right? And I just add the numerator. So I just add 1 plus 3. And 1 plus 3, all right, is equal to 4. So 4 out of 5. I cannot find a number which divides exactly into 4 and 5. So 4/5 cannot be simplified further. So that is the final answer. All right, boys. Now, let's work another example. We have 3/8 plus 3/8. Now, the denominators are the same, all right? So the number of parts that the diagram is divided in remains 8, all right? So my total, when I add the 2 parts, they are out of, okay, they still remain out of 8, all right? So out of 8. I just need to add the numerators only. So 3 plus 3, that is equal to, right? That is equal to 6/8, right? Now 6 and 8 are both multiples of 2. They are both even, so I can divide top and bottom, numerator and denominator, by 2. 6 division by 2, it's 3. 8 division by 2, it's 4. All right, 3/4 cannot be simplified any further, so that is the final answer. So 3/8 plus 3/8 is equal to 6/8, but 6/8 can be simplified, all right? Can be divided, top and bottom can be divided by 2, which is equal to 3/4. Let's start subtracting now, boys. We're going to subtract fractions with the same denominator, all right? Let's start with a real-life example, okay? Let's say that I took 3 pieces of chocolate from a whole bar divided into 4 equal parts, all right? Now, if I had to write the fraction, that would be equal to 3/4, 3 pieces out of a total of 4. Then I decided to give 1 piece from my pieces, all right? From 3 pieces, I'm going to give one piece out of a total of 4, so the fraction would be 1/4, all right, to my sister. So I'm going to give 1/4 to my sister. What is the fraction of chocolate? What is the fraction of chocolate that I eat? That I eat. So, if I gave 1/4 to my sister, all right, I am left with, all right, to calculate what is the fraction that I am left with, okay, I am subtracting 1 out of 4 from my 3/4. I am removing, subtracting, all right. So from the 3/4, all right, I am removing, so to speak, I can mark it on the diagram. I am removing, all right, I am giving 1 part out of 4 to my sister. So from the 3/4, I am subtracting the 1/4. Look at the diagram, boys. I remained with 2 parts out of a total of 4, 2/4. And 2/4 can be cancelled, all right? I can divide top by 2 and bottom denominator by 2 to be equal to 1/2. What is happening, all right? So I just, when denominators are the same, all right, I just subtract numerators, okay? So when, let's write it down. So when numerators are the same, when denominators are the same, subtract numerators. Okay, so when denominators are the same, subtract numerators, all right? Let's discuss another example. If 5 pieces of a pizza, okay, which are colored in red, right? If 5 pieces of a pizza initially divided into 8 equal parts are left, all right? So initially 5/8 of the pizza, 5 out of 8, 5 out of 8 are left. Then I decided to eat, so from those 5 pieces, I decided to eat 3 pieces. So I decided to eat 3 pieces, all right? I decided to eat 3 pieces out of 8. So I decided to eat 3 pieces out of 8. What fraction of the pizza is left? I'm left with 2 parts, boys. If you look at the diagram, don't calculate anything, just look at the diagram now. I'm left with 2 pieces out of a total of 8. So I'm left with 2 8s, all right? So I'm saying that 5 8s minus 3 8s, all right? That is equal to 2 8s, all right? The denominators, boys, are the same. Look, the denominators are the same. So what is happening? I am subtracting the numerators only. 5 minus 3, 2 8s. Now, 2 8s can be simplified further. They are both multiples of 2. So I'm going to divide top and bottom by 2. 2 division by 2 is 1. 8 division by 2 is 4. So 2 8s is equal to 1/4. Now, subtracting fractions with the same denominators is very simple and similar to addition as we just saw. Your answer will have the same denominator. If you look at the previous example, 5 eighths minus 3 eighths is equal to 2 eighths. Your answer will have the same denominator. So just subtract the numerators, and if you can, simplify the new fraction to its lowest form, alright? Just like we did. For example, 5 sixths minus 3 sixths. I have same denominators. So I just subtract the numerators. 5 minus 3 is 2. 2 out of 6 can be simplified. I can divide top and bottom by 2. 2 division by 2 is 1. 6 division by 2 is 3. Alright? Let's work on an example together now. 11 twelfths minus 7 twelfths. The denominators, boys, are the same. Alright? So the denominator remains the same. I just need to subtract the numerators. 11 minus 7. Now, 11 minus 7 is equal to 4. So 4 twelfths. But 4 twelfths, both 4 and 12, alright, are multiples of 4. Alright? So I can divide top and bottom by 4. So my answer eventually is 4 division by 4, it's 1. And 12 division by 4, it's 3. 1/3 cannot be simplified further, so that is the final answer. Okay. Your homework, boys, would be very similar to this lesson. Alright, you're going to have examples in which you have sometimes you're going to have addition examples, and at times subtraction examples. You're going to have a mixture, but having the same denominator. So pay attention. Pay attention also to simplify your answer whenever necessary. Okay, so if you need to reduce the fraction to its lowest terms, pay attention and check that you do so. Alright? So good day for now, boys, and take care.